So what will be the healing moment equal to, beta? Healing moment MR will be equal to 0.2 into V naught square is 9.262 square into displacement of 21,000 tons into kg of 8 meters into 10 by 2, that is 3 meters, divided by the length of 220. Do you agree with me? This is equal to 0.2 into 9.262 square into 21,000 into 3 upon 220. This is kilonewton meter, correct, beta?
Yes, sir.
530.46.
Or leave it like this, no problem. Okay, you are calculated, fine, fair enough. Beta, to
Yeah.
at the angle of equilibrium, the healing moment will be equal to writing moment.
Writing moment, sir.
Rotating moment.
And what is the formula for writing moment from what we did?
Yeah.
Mg sine theta, correct?
Yes,
Mg gm sine theta, right?
yes, yes.
Mg gm sine theta, correct, beta?
Correct, sir.
What is the mass of the ship? 21,000 tons. Correct. What is G? 9.81. What is the GM of the ship? KM is given in the question. Just see. KM 8.8.
Yes, sir.
KG 8. Any mention of FSM?
0.8. No, sir.
0.8. Right here, FSC 0
Not.
as not given. So therefore, GM will be 0.8. Right, guys?
Correct.
Okay. So M into G into GM into sine theta. You can now calculate, do sine inverse and give me the value of theta, guys. What is the requirement? Using this healing moment shall not be greater than 10 degrees. Correct, beta?
Correct, sir.
It is less than 10 degrees, so the vessel is complying with the requirements, right? Motion. There is a force which is required to keep it in circular motion, uniform circular motion. There is a force which is required to be there. If you remember something from 8th, 9th standard discussion, some of you may be able to recall, there is a force called a centripetal force, which is required to keep it in the circular motion. If there is nothing acting as a circular centripetal force, the body cannot be in a circular motion. Okay. Now, to which side does the centripetal force apply? The centripetal force applies towards the center of the circle, center of the turn that the object is in taking. It is acting towards the center of that particular circular path which the body is trying to take. Now, in schools, we have also learned as to what is the formula of the centripetal force in physics. I'm talking about physics from 8th, 9th, 10th standard somewhere, where the formula for the centripetal force is this one. It's mv square upon r. Now, since it's from physics, today the day has come when we need to very clearly distinguish between mass and weight. In ship stability, we have been taking a lot of liberty, beta, in removing G and saying pressure is tons per meter square, thrust is in tons. When we say what is the weight of the ship, we say tons. Okay, we have been taking a lot of liberty, but today we are using this formula from physics. And in this formula, this M here is strictly the mass. Mass means mass. Okay, and in this formula, this mass is in kg. Mass can be in tons also, never mind. In this formula, this V is the speed of the body, and the speed is in meters per second, not in knots. And in this formula, this R is the radius of that circle in meters. That is how this formula was there, and that gave us the centripetal force in newtons. So this formula in physics was centripetal force in newtons will be equal to mv square upon r, where m is the mass of the body in kg, v is the speed or the velocity, and r is the radius. Understood, guys? To be centripetal force. But what provides the which force is acting as the centripetal force? Now that depends on the type of motion or what is in circular motion. For example, if you tie a stone to a string and rotate it like this, then the tension in the string is acting as the centripetal force. The tension is providing the centripetal force, which is keeping the stone in a circular motion. So in this case, what is providing the centripetal force? It's the tension in the string. Okay. Likewise, you must have seen when you ride a cycle or a bike, when you take a turn, you bend into the turn. Why? Because there also centripetal force is required when the rider inclines like this. When he inclines like this, the reaction which is acting like this can be resolved into r sine theta towards the center of the turn, and r sine theta reaction, the horizontal component of the reaction, provides the required centripetal. Anyway, this has nothing to do with what you will do in your thing. This is only to connect that it is all linked to science. It's not something which has suddenly been thrust upon us. Okay. So now when a ship takes a circular turn, what happens to a ship? Now
Sir.
we'll derive, yeah, tell me.
Sir, do you have photo from last to last slide, sir?
Beta koi zarorat nahi, mv square upon r is the centripetal force. That's all. That was the only formula, beta. Mv square upon r is the centripetal force. Okay.
Okay.
Okay. Now we'll derive this formula for our heel during turn. Now there is one step which precedes this, which I'll be removing. So when you do in ship handling, somebody will talk of that step, but I am doing this derivation from the point of view of you being able to present it in the exams. Why? Because it has been asked once in 2013. It has been asked in 2013 once. Okay. Now, you see, when my ship is like this, usually what is more? KB is more or KG is more for our ships? What is more? Usually KG is more, yes or no, beta? Correct?
Yes,
This is how my ship is like this. Okay. Now what happens is, if I give this helm, now here is the rudder of the ship. Now, when you give a helm, let us say port starboard, I'm just for the sake of discussion, I'm using, it can be either side. When I give the helm to port, what happens? My rudder turns to port. Where is the rudder? Rudder is at the bottom of the ship. Yes or no, beta? Correct? Yes or no? Exert force on the rudder. Okay. Now, okay, one, it will affect the speed of the ship. Second, what will it do? It will also have a transverse thrust. Do you think this will cause a transverse thrust to starboard side or port side? Look at the force acting on the rudder. The sideways thrust, will it cause on the starboard side or port side? On the rudder.
If you are turning to port, then starboard side.
Arey, rudder is already there. No, I have marked the rudder, mere bhai. Let's talk about the situation now. So in this case, will it be to starboard or port? The transverse thrust on the rudder.
Port side.
Starboard, sir. Starboard.
Okay. Now, and where is it acting? Is it acting at the deck level, at the keel level, or at a low level or high level?
Keel level.
At deck level. Deck level.
Lower part goes to starboard, the upper part will go to port. So that will be called as port heel, correct, beta?
Yes, sir.
Correct.
Yes.
Okay. Now, this is what happens initially the moment you give the helm. And this is the step I'm going to skip now. Because tomorrow somebody talks about it and then you should not say, sir never told us that this will happen initially. This will happen initially, yes. But we are not going to discuss what is happening initially. We will straight away jump to when the ship settles into a uniform circular turn. When she settles into a uniform circular turn. Okay. Now, when she is turning resistance on this part, yes or no, beta?
Yes, sir.
Yes, sir.
That is called as lateral water resistance. Okay. This lateral water resistance, in this case, when you are turning in a circular motion to port, is going to act on the starboard side. If you are turning to starboard, it will act on the port side. This lateral water resistance in case of a ship in a uniform turn is the force which provides the required centripetal force. We just now saw that for a stone being whirled around, the tension in the string was providing the centripetal force. For a cyclist, the horizontal component of the reaction was providing the centripetal force. For a ship in a circular turn, the lateral water resistance on the opposite side is what provides the required centripetal force. Correct, beta? Understood? So, pehli cheez you have to remember is for a ship which turns, and why, when I'm saying first you have to remember is to help you in being able to derive the formula. So, first thing you have to say, recall is that when a ship settles into a circular turn, the centripetal force is provided by the lateral water resistance experienced on the opposite side. That is the first point you will write. If you want to write, you can write. When a ship is in a circular turn, the required centripetal force is provided by the lateral water resistance acting on the underwater hull of the ship on the opposite side. Am I clear, guys?
Yes, sir.
The second point that you can write later on. This force will act, can be assumed to be acting through what?
Buoyancy.
Through the geometric center of this entire area. Yes or no?
Yes, sir.
Correct. Now, to keep the thing simple, in derivation, it is assumed that the geometric center of this lateral water resistance is at the same level as the center of buoyancy. You can see it is more or less at the level of buoyancy. So, next point. This centripetal force, which acts towards the center of the turn through the centroid of the underwater area on the opposite side, comma, is assumed to act through the ship's center of buoyancy, because it is more or less at the same level. You can see in the diagram that if I try to find the center, that will be slightly higher than buoyancy, lower than buoyancy, but there will be not much variance. Is that clear, beta? Correct? Understood?
Sir, can you repeat one more time the last
From
paragraph?
where? From where?
So the centrifugal force acts.
A minute. Which force?
Centripetal force acts towards the center of the.
The centripetal force, which is acting through the centroid of the lateral water, underwater area on the opposite side, is assumed to be acting through center of buoyancy. Okay, beta? Okay. Now, what is this force equal to? This force is equal to mv square upon r, correct? Why? Because it is centripetal force. In this formula, what is m? M is mass. Please remember, what is m? M is mass. Beta, as per Newton's third law of motion, to every action there is equal and opposite reaction, correct?
Yes,
As
sir.
per Newton's law of motion, there is equal and opposite reaction. So if there is a centripetal force acting towards the center of the turn, then there will be equal and opposite force which will act, which is generated because of Newton's third law of motion. Okay, and that is called as centrifugal force. That is called as the centrifugal force. Okay. Now, centrifugal force, since it's a reaction, it by default always acts outwards because opposite direction, and acts through the center of gravity of the object, whether it is the cyclist or it was the stone, whatever it may be, or the ship. So the centrifugal force, which is reaction to the centripetal force, will act outwards through the center of gravity of the vessel. So you can write down this next point. The reaction to the centripetal force, called as centrifugal force, acts outwards through the ship's center of gravity, COG, through the ship's COG. The reaction to the centripetal force, called as the centrifugal force, acts outwards through the ship's COG. Understood, beta? Understood? Okay.
Yes, sir.
So that means the centripetal force acts like this. This is my mistake. This is centripetal force. This is centrifugal force. And reaction has to be equal to the action. So this force is also mv square upon r. Correct, beta? But acts through G. Am I right? And what do you have? Now you have two forces, centripetal and centrifugal. Both are equal, both are parallel, and both are opposite. So both these forces are equal, opposite, and parallel. I must have also used earlier. What do they form? They form a couple, right, beta? Correct? What does the moment of the couple do? Look at this. The centripetal force is tending to push the lower part of the ship to port. The centrifugal force is trying to push the upper part to starboard. The moment of this couple, will it try to heel the ship to port or starboard in this case?
Port.
Starboard.
Starboard.
Correct. So my ship will start heeling to starboard. Why? Because of this couple formed by the centripetal and centrifugal force. When my ship starts heeling because of any reason, whether it is this moment of this couple, or it is wind, or it is wave, what resists, what opposes the heel? Righting moment, yes or no?
Yes.
Correct, beta? Yes or no?
Yes, sir. Yes, sir.
So when the ship starts heeling, the righting lever comes into existence. That starts causing the righting moment. And as long as the heeling moment continues to be more than the righting moment, vessel will continue heeling. And when both become equal, that will be the angle of heel at which the vessel will reach an equilibrium. Yes or no, beta? Correct?
Correct, sir.
The vessel will reach an equilibrium at an angle of heel where the heeling moment caused by this couple becomes equal to the righting moment. So a ship turning to port will now heel to starboard and come to some angle of equilibrium. I'm making it bigger intentionally. Here was my B. Here is my G. Okay. Now B has shifted to B1. This is my line of buoyancy. This is the angle of heel. This is the angle of theta, is angle of heel due to turning. Because here the vessel has reached an equilibrium. Is that clear, beta? To equilibrium condition, right diagram. Equilibrium condition. Now, what is centripetal force acting through? Centripetal force was acting through B. That was also just an assumption that, okay, the centroid of the force will be somewhere in line with the center of buoyancy. So we don't shift that. This continues to act through mv square upon r, continues to act through the B. Why? Because in any case, there was already an assumption in the left diagram also that the geometric center of this area lies at the same level at B. So now B shifting to B1, little bit up or down, is not going to make any difference because we are already started with an assumption earlier. So we continue that the centripetal force continues to act through the buoyancy. So don't get confused with B1 now. Okay, that's why I'm pointing out before you start asking. What is centrifugal force acting through? Through G. In the equilibrium condition, I'm asking in the equilibrium condition, what is the lever of these two forces? It is the perpendicular distance between them. Correct, beta?
Correct.
Gx is the perpendicular distance between the two forces, yes or no? Correct? Correct, beta?
Correct.
And
Correct.
what
Yes,
will
sir.
be
Yes, sir.
this angle will be theta.
Theta.
Okay. So now the moment of the healing moment, rather, the healing moment in the equilibrium condition will be equal to one of the two forces, whichever you take, multiplied by the perpendicular distance between them, which is Gx. And from this right angle triangle, guys, what do you get Gx equal to? It is Bg cos theta, correct, beta? Bg cos theta, yes or no? Cos
Yes.
theta will be equal to Gx upon Bg, right? So this is healing moment, not heal. This is healing moment will be equal to mv square upon r into Bg cos theta, yes or no?
Yes, sir.
This is my equation 1. Okay. Now, if the ship has come to an equilibrium condition in this condition, what is righting moment equal to, beta? What is righting
Yes.
moment equal to? W into Gz. And for small angles of heel, Gz is equal to Gm initial sine theta. Yes or no? Correct?
Yes, sir.
Yes.
And what is W?
Displacement.
Weight.
Wait.
Correct? Right? So today, if the mass of the ship is m, then what will be its weight? Weight will be m into G. Yes or no?
Seven.
Correct, beta? This is weight multiplied by Gm initial sine theta. Yes or no? This will be the righting moment of the ship in the equilibrium condition, beta?
Yes, sir.
Yes, sir.
So 1 minute, I lost track.
Equilibrium in condition number 2 in diagram to the right. If the vessel is in equilibrium, that means at this angle theta, the righting moment should be equal to the healing moment. Must be equal. They must be equal. That means, what are we saying? At angle of equilibrium, mg into gm0 sine theta, which is the righting moment, should be equal to the healing moment, which is mv square upon r into bg cos theta. Yes or no? Correct, Peter? I've equated the two because the ship is in equilibrium, so both have to be equal. Otherwise, if one was more, then either she should have healed more or she should have healed less. Yes or no? Correct?
Yes.
And m get cancelled out. If I bring cos theta to the left, sine theta by cos theta becomes tan theta. And I take everything else to the right, it becomes v square into bg upon r into g into gm initial. This becomes the formula for heel during turn. V square into bg upon r into g into gm becomes the formula for heel during turn.
Correct.
Now write down. Now draw this diagram to the right one. The right diagram. Draw this bigger diagram now. Below this point, you can draw this diagram below this point. And write down this is the diagram in the equilibrium condition, right? This is the diagram in the equilibrium condition. Yeah, you just draw the diagram, then we can write down below. Draw the diagram. Why I'm dictating it is because once this derivation has been asked, then you should not be struggling to figure out what to write. Okay, sir told us to do like this, but how do I put it down now?
So what is this
Taken down.
O in the GMO?
Sorry,
This O in GMO, what is that?
Okay.
Down.
Initial metacentric I, zero upright condition beta. I instead of instead of I prefer to write zero because initial is confusing to people. They start using the word like GM initial and GM final.
Okay.
Okay. GM initial is the GM when the vessel is upright. GM zero is same as GMI, right? Okay. Drawn the diagram, guys.
Yes, sir.
Yes, sir.
In this diagram, you have drawn the perpendicular from G, mark GX, mark
sir.
theta, and then now in next point, in the equilibrium condition above, as drawn above, in the equilibrium condition as drawn above, healing moment is equal to mv square upon r into gx. ये वाला चीज, please write down this part. Okay, healing moment is equal to mv square upon gx, which is equal to mv square upon r into bg cos theta. So healing moment is equal to mv square upon r into bg cos theta, right guys? Understood?
Right.
इसी के नीचे लिखो writing moment is equal to rm is equal to small m into g into gm initial sin theta. mg gm sin theta. G is acceleration due to gravity. Now next line, as in equilibrium, healing moment is equal to writing moment. Equate the two moments and come to this formula tan theta beta, please. Close out this formula, and that is the derivation. If you recall the formula, it says tan theta is equal to v square into bg upon r into g into gm initial, right? Initial, whatever you want to say. Okay. Now, what do you need here? You have the kg given. What will you need for bg? What do you need, beta? If kg is given, kb, correct, beta? Okay. What will you need? Km for getting the gm. You'll need displacement for what? For FSC. So what are the steps involved? Can you first please calculate the height draft and give me the height draft of the vessel? Calculate the height draft and give me the height draft, please. Get bg. And you'll need km to get the gm in the formula. So you have to see what all you require in the formula. Accordingly, you'll decide what all to interpolate. So can you please interpolate these three things and give me the value? First, we need the speed. Better, I told you speed has to be in meters per second. What is our speed given? It's given 13 knots. What does it mean? That means the ship is doing 13 nautical mile in 1 hour. Knot is nautical mile per hour. So now, if numerator has to be in meters, then it is 13 into 1852.3. This converts the numerator to meters. Divide by 60 into 60 becomes seconds. 1 hour has 60 minutes, each minute has 60 seconds. This will be in meters per second. If you want to solve it, you can solve it up to 3 decimal places. If you want to use like this in the formula, it's your choice. If you want to solve it here, 6.689 meters per second. Guys, please confirm if the conversion from knots to meter is clear to everybody. kb and kg. kg is 7 meters. kb is 4.262. And this gives us bg, that is 837.2.738. Correct, beta? Radius of turn is given in the question as 400 meters. G, we know on surface of Earth is 9.81 meters per second square. GM0 or GM initial, whatever you want to write, will be the km, that is 8.252. minus the kg of the vessel, that is 7 meters, that is GM solid, minus FSC. FSC will be FSM upon displacement of 16678.3. How much is the GM initial coming then, Vita?
Sir, 1.180.
180. Okay, 180 meters. Okay. Now we have everything that is required in the formula. It just needs substitution and tan inverse. Tan theta is equal to 6.689 square into 2.738 upon 400 into 9.81 into 1.180. This gives us theta is equal to, you can give me in degrees up to 3 decimal places.
1.51 for opposite.
1.5.
1 for opposite. 1.5
degrees on the opposite
1
side,
degree,
or on the outboard side or outer side. Yeah,
1 degree,
opposite side.
30 point,
Yeah, okay. You can give in minutes or degrees. That's your choice. That's okay.
1.151.
Yeah, okay, fine. But the
1.15.
degrees, yeah, on the on opposite side, right? Whichever side opposite to the turn, right? Or outer side, or you can say opposite or outer side, whatever you want to say. Inner side and outer side can also be used, right? Now, why is it outer side? You have to give the reason here. Why you said outer side? Because kg is greater than kb. Why? If you go back to this diagram beta here, see, she was turning to port, but she heeled to starboard. Why? Because G was above B.
Greater, sir.
Tomorrow, if you have a situation where you create kb is greater than kg, then the ship will heel into the turn, right, beta?
Correct, sir.
Okay. So whether she is going to heel into the turn or outwards, inwards or outwards, will depend upon whether kg is greater than kb or less than kb. Normally, our kg is greater than kb, so normally the ships would heel outwards. But tomorrow, if I create a situation and say kb is greater, then the ship will heel inwards. So don't always say that ships have to heel outwards only. But yes, if somebody says, why do ships heel outwards? That means he's saying why generally they heel outwards. That is because generally the kb is less than kg. Correct, Vita? Out instead of outer. Yes or no, Vita?
Yes, sir.
I don't think this question needs discussion, right?
Correct.
Okay.
Last question.
Of heel on now. These are special. These are not the only ones, guys. These are special. That means additional. Additional to what? Additional to the other stability requirements which you studied in phase 1. Over and above that, the passenger ships have some special criteria. One of them is the angle of heel on account of crowding of passengers on one side shall not exceed 10 degrees. That is one requirement. The rest all are additional information for that. Where will the kg of a sitting passenger will be taken? Where would be the kg of a standing passenger be taken? Now those are additional things. But what is the requirement? That if all passengers crowd on one side, the heel of the ship should not exceed 10 degrees. Then there is a second requirement also, guys. The second requirement is the angle of heel on account of turning. Angle of heel on account of turning shall not exceed 10 degrees. The passenger ship has to show that when she turns, the angle of heel due to turning will not exceed 10 degrees. Now you'll say, sir, our formula was this: tan theta is equal to P square BG upon RGGA. Sir, what speed? The ship can be moving at different speeds. Yes. Sir, the ship can have different kg. Yes. BG will change. The ship can have different draft. The kb will change. Yes. The ship can take turn of any radius, sometimes less, sometimes more. So GM of the ship can change. So When we say the heel should not, how, at what speed, for what radius, for what GM should the vessel demonstrate its compliance? Correct? That question will come up, no? Yes or no, beta?
Yes, sir.
Correct? When you have to demonstrate compliance, you will have to demonstrate at some standard conditions. So what is it saying? In addition, the angle of heel on account of turning shall not exceed 10 degrees. And to establish this compliance, only to establish this compliance, we will not use this formula. We will not use this formula. To demonstrate this compliance, the following formula has to be used. And this formula is given in the code of intact stability, guys. Okay. So for only for compliance. Now, one thing before I discuss this formula, this does not mean that tomorrow instead of MV inch, if I say a passenger ship is turning in so and so radius at so and so speed and so, what is the heel cost? Now, the formula of tan theta applies to all types of ships. It applies to passenger ships also. Okay. So when you have to find the heel cost normal in a normal scenario, then you'll apply the tan theta formula. Only when the question wants you to establish whether the vessel is complying with this requirement of intact stability or not for passenger ships, then only this formula would be used. So is it clear when to use this formula? Am I clear, beta? Compliance has to be shown when the vessel is moving at its service speed. What is this? This is displacement. What is D? Draft. AG. And this is the heeling moment. So to establish compliance, the heeling moment in kilonewton meter will be calculated by this formula. Now you'll say, sir, how has this formula come? That is out of context actually. It is not there in the code of intact stability, but it will help you in remembering the things. If you remember, our heeling moment was what? mv square upon r into bg cos theta. Yeah, remember in the derivation, beta, mv square upon r into bg cos theta.
Yes,
Yes,
sir.
sir.
That was our heeling moment. Yes or no? You can go back in the
Yes.
derivation and see what was the heeling moment. Same.
Same, sir, same.
Same, sir.
Now, so here this mr is the heeling moment, but how this heeling moment has to be calculated? By this formula. Now, what is this formula? Formula is this, that cos theta when heel is less, cos 0 is 1. As the theta is less, this will be practically 1. So they said leave this out for this particular compliance. So this has been left out. Why? Because heel come hoga maybe couple of degrees. Maximum allowed is 10 degrees. So it is very close to 1. So leave cos theta out for compliance. Why unnecessarily complicate the compliance calculations? What is BG? BG is kg minus kb. Yes or no, beta?
Yes, sir.
Correct. So what have they said? For compliance, take kb equal to d by 2, and that becomes BG. So this actually they have substituted for BG. Understood?
Yes, sir.
Okay. Then they said, what speed should we take? They said, take it at service speed V0. V0 is the service speed of the vessel. Fine, that's okay. Then M is the mass. Now, in our formula, this mass was in kg. In centripetal force formula, the force was
Yes,
in newtons, and it was mv square upon r, right? If I take this mass into tons, this will become kilonewton. So what has he done? He's taken the displacement of the ship in tons, you see. So this mass is here and it has come in tons. Why? Because mr is in kilonewton, you see. Mr has been made into kilonewton. Okay, beta. So bg is done, v0 is done, and displacement is done. Now, what is the radius for compliance? which they want to carry out at. They want to carry out this turn at a radius which is 5 times the length of the vessel for compliance. Actually, the ship may execute a radius of less or more, but for compliance, they have taken the radius to be 5 times the length. So if instead of R, I put 5L here, then you have L in the denominator and 1 by 5 becomes 0.2. Is that clear, beta? Understood?
Yes,
So
sir.
the passenger ship complying with the stability requirement for heel during turn. When it is a question of compliance, then you will use this formula to get the heeling moment. Is that clear?
Yes, sir.
Clear, beta?
Yes, sir.
Okay.
Sir, I have one doubt.
Yeah, tell me. He says, does she satisfy intact stability criteria regarding heel during turn? Is that clear, beta? In this part, he's saying find the heel during turn. This could be, I can say, a passenger ship. Let me insert a word here. Passenger ship turns in a port in a circle of radius this. Find the angle of heel. Now, can you understand the difference between this one and this one? Yes or no? Please go through. So there should not
Yes,
be
sir.
any doubt. There should not be any doubt when to use which one. That is the first and foremost thing, So this is the part A of this question is the derivation which we have already done, guys. That is tan theta derivation he's talking about. And part B is this part. Just now, what did we learn? That when you have to show compliance, so we are not doing this, we are doing this one. When compliance is to be established, then you have to calculate the heeling moment MR, whose units will be kilonewton meter, and the formula is 0.2 into V naught square into the displacement of the vessel into BG was substituted by kg minus T by 2 divided by the length. Yes or no, beta? Was this the formula? G by 2, yeah, that's correct. Remember this formula? Is this correct that I have written? Just see. 0.2 V naught square L displacement kg knots. Can you convert 18 into 1852.3 upon 60 into 60 meters per second? Can you please calculate and give me the value? 0.262 meters per second. Okay. V naught is there. Displacement is given as 21,000 tons. So let's pull out all these values. Kg of the ship is given as 8 meters in the question. The draft of the ship is given as 10 meters here. Then length of the vessel is given as 220 meters. So everything is given to calculate this.